No? Okay. Today we have to start a new session under transaction processing. Last time we started transaction processing. So introduction part has done. So then we have to uh, discuss about transaction processing, system log, ACID properties, commit points, right? So these are the outline of this section, transaction and system concepts. So, and what is system log, then commit point of transaction, and what are the ACID properties. So these things we'll be discussing uh, in this section. So transaction and system concepts. So uh, according to according to the definition, a transaction is an atomic unit of work that should either be completed in its entirety or not done at all. So that is this is the uh, definition, right? So if a particular transaction uh, must be should be either be completed in its entirety or full or not done at all, right? So in between there is no situation, then uh, a transaction is a atomic unit, right? So atomic unit means component of large activity which can't be divided further, right? So transaction is a particular small activity that should either be finished or aborted. So according to the previous lecture, we see that a transaction includes several operations like read data items, write data items. So therefore, a transaction is completed mean it's all the operations has been completed, right? A transaction does not at all mean a transaction uh, not done, right? A transaction not done at all mean uh, not completed any single operation in the transaction. So it is the meaning of transaction must be completed or either uh, not done at all, right? So in other, then we take uh, right in order to recovery purposes, right? So in order to recovery purposes, the system needs to be keep track of information about when each transaction starts, when terminates, when commits, transaction is done, or when abort transaction done, right? So for recovery purposes, we need these information uh, keeping in database, our database management system, right? For recovery. So, mm. So there is a recovery manager for a database management system, and this recovery manager keep track of when each transaction starts, terminates, commits, and aborts. So keeping track of this information is required in recovery purposes. Therefore, the recovery manager of database management system needs to keep track of these information of each transaction. So, first one is begin transaction, right? Begin transaction. This marks the beginning of transaction execution, right? Beginning. Next one is read or write. This marks the read or write operations on database items. Next, end transaction. So this will specify the end of read and write operations of the transaction and marks the end of the transaction. So this end transaction does not this end transaction does not marks that the transaction is completely done, right? So even though in transaction it is not marking that the transaction is completely done, right? Here commit transaction, this commit transaction marks the transaction is completely done or permanently done, right? So this point will mark the completion, right? Commit transaction. Then here end transaction means the transaction is completely completed temporarily and everything are not written on database. Even though transaction finish, still uh, things are or modifications are not written on database. But when perform commit transaction means the everything done by read and read or write operations in the transaction were written database permanently, right? So commit transaction means all the operations, modifications uh, are written on database permanently, right? So here rollback or abort, rollback or abort if transaction ended unsuccessfully, right? Uh, the transaction rollback. So if uh, particular transaction ended unsuccessfully, then the transaction rollback, right? That means the database recovered to the initial state or all the operations undone, right? So if we run rollback, what happened? Everything reverted. All the modification revert back to the initial state, cancel, right? This is the states transition diagram of a transaction. This is illustrating the state for transaction execution, right? When a transaction executing, various states are available. So this will show uh, states for transaction execution, right? Here, beginning a transaction, this is the beginning of a transaction. This is active state of transaction, right? In this active state, all the read and write items are performed. All the read and write operations, or all the read and write items are performed in this active state. After completion, all the operations of the transaction completed in this end transaction occurred, right? End transaction occurred. We say this is partially committed, right? Here, partially committed. After finishing this operation, then end transaction, then we say partially committed state. So after partially committed state, uh, when commit transaction occurred, everything will be written on the hard disk permanently, right? Here, uh, within this committed transaction, the everything will be saved to hard disk or database permanently. Finally, transaction will terminate, right? Yeah, these are the states, right? So while active state, there is a possibility to abort the transaction. So various issues occur. If a issue occur, then it may be failure. So then transaction may be aborted, right? Transaction may be aborted. Then the transaction goes to fail state. Then this is the fail state, and finally transaction terminated. So when successfully committed and the transaction terminated. Also, if any failure occurred, then transaction aborted and finally goes to terminated. So this is the uh, state transition diagram, right? State transition diagram of a transaction. So here between the end transaction and committed transaction, it is a partially committed state, right? Partially committed state. So in partially committed state, there is a possibility to abort, right? In partial state also there is a possibility to abort transaction, then fail, right? Uh, then fail, right? Here, partially committed, there is a possibility to abort, then transaction uh, fail, right? Uh, then finally, after failed, finally, the transaction terminate here, right? Actually, various path, right? Uh, for example, uh, in partially committed state, we have two transaction called T1 and T2. For example, uh, there is a two there are two transaction T1 and T2. They are executed interleaved manner. So you can remember what is meaning interleaved manner. Each and every operations in a transaction are running together, one after the other. Right? One operation from one transaction, another operation from another other transaction. Likewise, one after the other. We call interleaved manner. Even though T1 completed, right? Even though T1 completed, T2 still executing, and it need some value to perform the transaction, and then it fails, right? So that means uh, if two transactions are executing in interleaved manner, if uh, if one transaction fail due to some requirements of value, uh, then other transaction need uh, that value which are coming with other transaction. Then that means then again uh, that also fail. then T2 fails mean T1 also fails, right? Uh, Both are executing interleaved manner, right? That means one. So here, uh, this if a particular transaction fail uh, in both transaction, other one also fail, right? This is state transition diagram of a transaction which show or illustrate state for transaction execution. Right? You can remember this chart easily. Right? Next one is system log. Right? System log. In order to recover from failures that affect transactions, we should keep track of all transaction operations that affect the data items, right? So system log keeps track of transaction operations, where the modifications are keep track. Uh, the system log is keeping track of uh, transaction operations. Uh, that is the place keep uh, operations, modification kind of things, uh, which are keeping in log, right? System log. This is similar to log file, right? In that log file, what we write is keeping track of all the transaction operations, right? That is commit, abort, right? Commit, abort, and etc. All those things written on this system log file. It is sequential append only file, right? It is sequential append only file. It not allowed to modify, only able to append records to its, right? So it is only keeping records, not deleting, right? First one is put in the log, then uh, another entry is uh, keep put after that one. Likewise, append only, no erase, right? The system log is not affected by any failure, right? But except this or catastrophic failure, because if a dispel means system fail, no? Dispel means or any catastrophic situation like flood or things, then hard disk may be finish or damage, then everything will be damaged, no? That means system log also uh, affected any failure, right? May be affected, right? Other than that, system log uh, not affected by any failure. The log buffer means keep track of transaction operation in a special file in a main memory. We call it as log buffer. When it is full, it will be appended to the log file in the disk permanently, right? So it is log buffer is another extra area, memory area in the main memory. Then it will time to time it will appended to the log file in the disk permanently, right? So temporary log buffer means temporary memory area for the log, right? Then uh, the log file is backup periodically, right? Uh, Log file is backup periodically. When required to recover the database, this log file can be used to recover the database, right? By using this log file, we can find all the transaction which modified the database, right? So these transactions can be undergone to recover the database. So undo and redo operations based on this log file is possible. Therefore, the database can be recovered through information recovered in the log file. So we can use this log file to recover our database. So this is how recording of the transaction used in the database system consists in the system log file. So this is the structure of the system log file. The first one indicates the transaction T has started the execution, right? So this is the starting point. So this one indicates the transaction T has started execution, right? The second one indicates that the transaction T has changed the value of database item X from old value to new value, right? Right item T. So what is the operation right item? T means what is the transaction name? X, what is the data item? Old value, new value, right? If we modify particular data item, then the system log keeping both old value and new value. So third one, right? Third one indicates that the transaction T has read the value of database item X, right? Database item X. Is fourth one, right? Fourth one indicates the commit of the transaction T to record permanently the whatever modification done by the transaction T on data items, right? So this will indicates or mark the commit permanently saving, right, to the database. The final one, right? The final one indicate that the transaction T has been aborted and reverted back to the original state of the database, right? So these are the 5 items written on the system log which can be used to recover the database. So using these information, we can recover the database in failure. So what does mean by commit point of a transaction? Right? So commit point of a transaction happens after all the database operations associated with that transaction have finished successfully, right? And also those effects uh, of operation recovered in the log file. After this commit point, if any transaction failure or system failure not occurred, it can be executed committed transaction and will be saved all effects of operations into the database permanently, right? Uh, Also, at the commit point, transaction writes a commit record into the log. That is commit T, right? So committee is append to the system log after this commit point, right? Uh, right. If permanently save modification, if you want a database want to save modification permanently, then that will occur in that uh, commit point, right? So after this commit, with this commit, log also updated with this commit T entry. So however, if a system failure occurs due to particular transaction fails, it can be searched the transaction that occurred the failure by identifying the transaction with no commit record, but already have start transaction, right? That is uh, start transaction T, right? So we can find if a particular transaction is failure by using this system log, because there is a start transaction entry, but there is no commit, right? Right. So therefore, we can understand that that transaction has uh, failure, no? Right. Finally, before reaching to the commit point of a transaction, it can be done force writing the log buffer to log file in the disk, right? So this means anything in the buffer log can be written to this log before reaching the commit point of the transaction. Right? So that means before running this commit point, uh, everything in the log buffer should be written to the hard disk or database. Then anything will not miss, right? No missing updates. Then after saving these things, modification in the log buffer to the disk, then uh, this commit point should be done. Then every modification will be saved to the database permanently. So I think you can understand this easily, simple thing uh, behind this scenario. No? These things you can understand easily. Uh, right. Here, this is uh, database management system specific buffer replacement policies, right? This is a policy or order kind of rule kind of thing, how uh, buffer is replacement, right? So all the database operations effects are keeping in main memory buffer, and when main memory full, it require to replace this from main buffer, right? So there are some specific buffer replacement policies in database management system, right? So this is how replace the main memory buffer, right? With the policy. First one is page replacement policy. This will select particular buffers to be replaced when all buffers are full. There are some database management system specific buffer replacement policies, right? First database management system specific method is domain separation method. Each domain handles one type of disk pages. There are different type of domains like index pages, data file pages, log file pages. Then available size of buffers for each domain is determined. So buffer size for index page can be fixed. Also, buffer size for data file pages can be fixed. And buffer size for log file pages can be fixed, right? This is a domain separation method. So this is how this domain separation method is occurred, right? When executing transaction, if index page buffer is full, it can be replaced in this instead of replacing data file pages buffer or log file pages buffer. So this method will divide buffer into three sets of pages, and it allow a replacement of particular domain without concerning other domains, right? This is known as domain separation method, right? This is something kind of rule uh, how buffer replacement are occur, right? This is second method is hot set method, right? Hot set method is second buffer replacement method. This method is useful in queries that scan a set of pages repeatedly. For example, if we use netted, if we use uh, uh, if we use nested join queries or looping queries, we are scanning same set of pages repeatedly. So those same set of pages require to keep in main memory. So hot set method is useful such situations. Uh, in this hot set method, buffers will not replace until processing is completed. Next buffer replacement method is dbmin, right? dbmin method. So this is a predetermined method to identify which pages should be kept in the main memory. For that, there is a algorithm called QLRSM, right? QL, sorry, QLSM. According to that algorithm, it can be determined with pro, which according to that algorithm, this algorithm, uh, it can be determined which pages should be accessed by particular query. So we can keep those pages in the main memory buffer. They can be accessed by that query when executing. So have a little understanding about how this buffer replacement are occurring when this recovery or this database log is updating, right? So this is very useful things, desirable properties of a transaction, right? Or properties of transaction, right? If we take a particular transaction, these are the properties of that transaction. Right? So we call it as ACID properties. So ACID term is created using first letter of words. Atomicity, A for atomicity, C for consistency, preservation, I for isolation, and finally D is for durability or permanency. Right? These are the four terms used in acid properties. The first acid property is atomicity. What is atomicity? The transaction should perform completely or should not perform at all. Right? We know that the transaction may consist number of operations. Right? So transaction should be performed completely mean all the operations of the transaction should be completed. Each and every operations, each and every single operation in that transaction should be completed uh, to transaction to be completed. Yeah. And a transaction should not perform at all means any operation of the transaction is not completed to completely You mean when? Completely aborted, right? So any operations of the transaction is not completed uh, means uh, transaction perform at transaction not perform at all, right? So at least one operation not finished. So second one is consistency preservation. That means a particular transaction should take a database uh, from one consistent state to another consistent state. For that, there should not be errors in transaction for its operations. Right? There should not be any inconsistent in database after the end of the transaction. Right? So this is keeping track of keeping the database in consistent state. Right? So this acid property, consistent preservation, is used to consistency of the database. Right? So it will ensure the consistency database, right? Then third one, right? Third property is isolation. So isolation means one transaction should not interfere to other transaction. So each transaction should be isolated. Even though two transactions are executing concurrently, each should not interfere to other transaction. So transactions are running interleaved manner, one after the other. So even though such interleaving executing, uh, each transaction should not interfere to other one, right? Then finally, fourth property is durability or permanency. Durability or permanency. Uh, right? Changes done by transaction must persist in the database. There should not any lost in database after completing a transaction. So therefore, transaction should ensure its durability or permanency of the database once completed the transaction. Right? So uh, you can understand using these terms what they mentioning, right? You can understand. Uh, Therefore, acid properties of transactions are atomicity, consistency, preservation, isolation, and finally durability or permanency. Uh, Here, atomicity, this atomicity is done by transaction recovery subsystem of the database. So keeping atomicity of a database is responsible of transaction recovery subsystem of the database management system. So next, consistency preservation should be achieved by enforcing integrity constraints of a database. So it should be responsible of the programmer who write database program by enforcing integrity constraints of the database. So constraints like primary key, foreign key, kind of integrity constraints. So these constraints are used by programmers, right? Uh, Designers, no? So that this is responsible of keeping consistency, is responsible of uh, programmer, right? Then isolation is a part of concurrency control subsystem of a database, right? Then finally, durability or permanency is responsible of a recovery subsystem of the database management system. So therefore, keeping acid properties is responsible of four different parties of the database management systems. Okay, so this transaction processing system log acid properties commit points is finished. So this is a subsection under transaction processing lecture section. No? So we can start another thing. Another short uh, portion of this lecture transaction processing, right? Transaction processing, characterizing schedules based on recoverabilities, right? Characterizing schedules based on recoverabilities. So this is the outline we are going to discuss in this subsection. This is what is schedule or history. Then notations that will be used, right? Notations. Then what does mean by complete schedule and what is the difference between recoverable and non-recoverable schedules? So these things will be discussed under this short section, right? First, let's see introduction to characterizing schedules based on recoverability. Uh, what is schedule or history? What is schedule or history? So when there are several transactions, they are executing concurrently in an interleaved fashion, right? That the order of execution of the operations from various transactions, right, is known as schedule, right? So a schedule law history means the order of execution of transaction from uh, uh, order of a schedule law history means order of execution of operations from all transaction, right? So that means mm, particular transaction may have number of operations, right? So in a schedule, uh, these operations should be placed in particular order, right? So that order we call as schedule or history. If we have a number of transactions like T1, T2 to the Tn, then there are several operations inside each transaction, right? If we take particular T1 transaction, this may have a number of operations. This T2 also may have number of operations. Likewise, all the transactions have different operations, right? Now, when we prepare a schedule, it means all the operations of these transactions will be there in that schedule, right? Somehow we have to put all operations in these transactions, right? So here, schedule S of transaction T1, T2 to Tn is an ordering of the operation of the transaction. So is an ordering of the operations of the transaction, right? This is the order. What is the order uh, of each transactions are placed in this schedule, right? So here T1, T2, Tn transaction may have several operations. So inside T1 may have five operations. For example, T1 may have five operations. Inside T2 may have six operations. Then we have to order all these operations, because they are executing interleaved fashion. It is not executing T1 after that T2 and after that T3, not like that. They mixing all these operations from different transactions, right? So all these operations we will call as schedule or history. So schedule contains operations from different transactions, and its transaction can be interleaved in the schedule, right? So all the operations interleaved. Uh, if we take a particular schedule, that schedule contains a number of operations which are coming from different transaction, right? Different transaction. So in that schedule, each and every operations are running interleaved manner, right? It's a very simple scenario, right? The total ordering of operation in schedule means for any two operations in the schedule, one must occur before the other, right? The total ordering of transaction in a schedule means for any uh, uh, for any two operations in the schedule, one must occur before the other. For example, uh, if there is a transaction T1 and there are two operations in that T1, Mm. First one is read item, right? Uh, uh, right? If we take a particular transaction in a schedule, uh, if that transaction T1 has two operations, first one is the read item and second one is write item. So in the schedule also, read item should be mentioned first and write item should be mentioned second. Right? It is the order. Same with the uh, transaction, right? The each operations uh, order should be maintained similar to the transactions uh, in the schedule also, right? Both places mentioning their order in same order. So in the schedule also, uh, if we take in the transaction, first mention uh, read item, then running write item. Then if we take schedule, also read item should be mentioned first and write item should be mentioned as second. Then the ordering should be same in both original transaction as well as schedule. Then we call it as total ordering of operations, right? Total ordering of operations. Right, I think you can understand it if we take this T1, right? If we take T1, uh, i- it has two transactions like first one is particular read X, right? Here, read X. This is the order. Next, write X, right? Write X. This is the transaction. So we have schedule, right? Schedule has different transaction and their operations. So if we take schedule, then first one, read X should be first, right? By T1, right? By T1. T1's read T1, right? T1. Right? There are another so many transactions coming from different transaction. Uh, this, uh, this operation coming from T1, right? Here, this read item X operation should be mentioned first in the schedule also. Then this write item X operation also should be mentioned after some operations coming from different transactions, right? But this original order should be maintained in this schedule also, right? Same order, right? Number of operations in this schedule. But if we take particular one transaction, its operation should be placed similar order uh, in the schedule also. Next, we have to delete these things. Right. Next, we have to see notations. Right. Notations. For our convenience, we simplified notations that we have already seen previously. Simple B is for begin transaction. Then simple R is for read item. Simple W for write item. And simple E for end transaction. Then C for commit transaction. And A for simple A for abort. In schedule, we will concern about R, W, C, and abort. Right? That means we are concerning only read, write, commit, and abort. Right? Normally, begin transaction and end transaction are not using in examples, right? Even though we have this in and end, begin and end, but we are not considering these for our examples and schedules when we discuss it. So we are concerning only about R, W, E, and C. Right? So that means we are dealing only about read items, write items, commit, and abort in a transaction. Yeah, let's see example of a schedule. Right? This is the schedule example. Here in the first diagram, you can see this first diagram. There are two transactions called T1 and T2. Right? This is a particular transaction. Right? So the schedule. There are two transactions in this schedule. So the schedule of these two transactions was read item X in T1. Here you can see it is mentioning here. First operation is read item X, right? Read item X in transaction T1. So this is the notation R1 X, right? Read transaction 1 item X. Read item X in read item X in transaction 1. Then we are not considering assignments. These assignments are not considered, right? This assignment is not considered. Normally, assignments are not considered. Therefore, we only concern about these operations, right? Read item X, right? Then next one is what is R2X. R2X mean read item X in read item X in T1. Read item X in T2. T2. Right here. This one first, next one, then next one, next one, next one. This is the order. This is the order, no? Order. Then again, write item X, write item X in T1. Next, read item Y, read item Y in T1. Next one is write item X in T2. And finally, write item Y in T1. Here, write item Y in T1. Right? So, how we mention these operations in a schedule. This is the method. This is the form we are mentioning operations in schedules. Right. If we write a schedule for these first two transaction, initially we have to give any name like SA, right? Uh, if we have to give a name, right? We have to give a name for a particular transaction, right? Transaction. Then what we do, the name is this schedule. The name is, we have to give a name for the schedule, right? Name for the schedule, that is SA. Why SA, right? SA. S means schedule A. Schedule A. Right? Then we have to put a semicolon, right? Semicolon, right? Then we keep mentioning this read item X like this, no? Like this, right? This is the syntax. This is the syntax how we mentioning or writing different operation in a schedule, right? If we write a schedule for transaction in second diagram, right? If we write a schedule for this second diagram, right? We write a schedule name. First, we have to write a name. That means SB semicolon. Then write item X in T1 here. Write item, sorry, read item X in T1. Then write item X in again T1. Uh, Next, read item X in T2. Write item X in T2. Finally, read item Y in T1, and there is a about in where A1 1 in T1. So T1 transaction aborted, right? Aborted, done by transaction T1, because we are mentioning uh, read, write, abort, and commit, no? Particular uh, in a particular schedule, right? Read, write, abort, and commit. There is another theory. So let's see what does mean by conflicting operations in a schedule. Conflicting operation in a schedule. So you can get a idea. Conflicting operations in a schedule. So we know uh, different operations are keeping in a schedule coming from different transactions, right? So we say two conflicting operations in a schedule if they satisfy all these uh, three conditions mentioning below, right? If these three conditions are satisfied, then we uh, say two conflicting operations. These two conflicting, if particular two operations are satisfy these three conditions, then we say these two operations are conflicting, or two conflicting operations. First, what is first one? First one is operations should be belongs to different transaction. Operation should be should be belongs to different transaction, right? Then second one is operations uh, access the same item X, right? Third one is at least one of the operation is write item X, right? These are the three uh, conditions should be satisfied to be conflicting operations, right? So, for example, in schedule SA here, operations R1X here, R1X will be conflicting with W2X, right? Here, this R1X is conflicting with W2X because these two operations satisfy all above three conditions. Two operations belongs to two different transactions, T1 and T2, R1X and W2X, right? So two means transactions name, no? T1. R1X is coming from T1 and W2X is coming from T2. So first condition is okay. Then operations access same X, right? Same X. So same database item is accessed by both operations. That means X is accessing. Then at least one operation in write item X, right? Third one is at least one of the operation is write item X. So that condition also satisfied. So therefore, we say these two R1X and W2X are conflicting operations. Similarly, we can see R2X and which one? W1X are conflicting. R2X and W1X because these two coming from two different transactions and same X is accessing and at least one is right, right. So therefore R2X and W1X are conflicting operations. Then R2X and W1X. Then also we can see W1X and which one? W2X, right? These two also conflicting, no? Because W1X and W2X means coming from two different transaction, same X is accessing and at least one right, no? Both are right, but at least one uh, should be right is satisfied, no? Then here R1X and R1X and which one? R2X are not conflicting, no? R1X and R2X are not conflicting because even though these two coming from two different transaction and same item is accessing, but third one is not satisfying, but it's at least one should be right, no? So the third one is not satisfying, therefore these two are not conflicting. Then when two operations conflicting, if change in their order will be resulted in different outcome, right? Here, so if we change their order uh, of particular conflicting operations, we have a different outcome. Here, R2X, right? R2X and W1X are conflicting. R21X and W1 is are conflicting operations, no? By changing these two, by changing order, it will first write item X, right? Originally read item X, then write item X, right? But if we change this order, first write item x by t1. This one happened. Then next read item x by t2. So after changing the order, read item operations of t2 will read modified value for item x. So which is modified by transaction 1. So that modified value will be accessed by transaction 2, right? Originally it is different, no? First read without modifications, right? So after changing, this transaction 2 will access the modified version of x, no? So therefore outcome will be different one, no? Outcome will be different one. So this kind of conflicts we say read write conflicts. Read write, right? Read write. That means if we change the order, then we have different outcome. Then another type is write write conflicts. For example, W1x and W2x both are right operation, but change in their order, there is no different in outcome. No? And, next, we will see about another theoretical definition in schedule, that is complete schedule. Complete schedule. A schedule is of a transaction said to be complete schedule if it is satisfy following three conditions, right? Condition 1 is here another thing, complete schedule. First one is for conflicting operations here. This one is complete schedule. This one also need three conditions, right? Condition 1 is the operations in schedule S dash are exactly equal to those operations in transaction T1, T2 to Tn. And also last operation should be commit or abort, right? This is the first condition. The operation in S are exactly equal to those operations in T1, right? So schedule also maintain the same order, uh, like similarly their original orders in T1 and T2, their transactions, right? Uh, right, same order, operations in their original transactions, and that order should be maintained in schedule also, right? So second condition is for any pair of operations from the same transaction Ti, their relative order of appearance in S is the same as their order of appearance in Ti, right? So you can understand, for example, if a transaction T1 has pair of operations like read and write, then in the schedule also they should be read first and next write should be second, right? Uh, Read first and next write should be second. So same order in both their original transaction as well as in the schedule. The third one, right? Third condition, for any two conflicting operations, one of two must occur before the other in the schedule, right? Uh, for conflicting operations, one of the two must occur before the other in the schedule. That means we don't need to mention which one should first, right? Therefore, same order, that is in both places, no? We don't need to mention specifically which one is first or which one is next. Likewise, if these two are conflicting operations. Here, partial order means in this third condition, we don't need to mention the order of operation when they conflicting, right? So we call it as partial order. So these are the three conditions for a complete schedule. I think this one also you can understand easily, right? Two different theories, right? First one is for conflicting operations. Second one is complete schedule, right? Complete schedule. Right. Next one is recoverable and non-recoverable schedules. Recoverable and non-recoverable schedule, right? So you know operations, right? Transactions can be recovered. No, if a failure occurred, we can recovered by using a system log. Uh, we can recover. So uh, here once so it described as recoverable and non-recoverable schedules. Here, once a transaction T is committed, it should never be necessary to roll back T, right? You know, if a failure occur, we have to roll back, right? If a failure occur in a transaction, uh, we have to roll back, no? Otherwise, the database in inconsistency state, no? Failure. So if a particular transaction is committed, then we don't need to uh, uh, roll back, no? Roll back. We don't need to roll back because it's permanently saved modification to the database by that transaction, right? A schedule where a committed transaction may have to be rolled back during recover is called non-recoverable, right? So here, a schedule where a committed transaction may have to be rolled back uh, during recovery is called non-recoverable, right? Here, sometimes in a schedule, uh, we know different transactions are in that schedule. No, if we want to roll back particular uh, schedule, right? If there is a committed transaction, then we call it as non-recoverable. So, but you know, if a particular transaction or modification permanently saved to the database, that means committed, then database management system not allowed to do that. No, should not be permitted by the database management system. So database management system not allowing to do that rollback or reverted back because it is permanently permanently saved, no? Permanently saved to the database. Right? The schedules that meet recoverable schedule conditions are called recoverable schedules, right? So there is uh, there is there are conditions, right? Uh, that should be satisfied. So if schedules uh, satisfy those recoverable schedule condition, then we call a recoverable schedule. This kind of schedules we call as recoverable schedules, right? So there are some recoverable schedule conditions. then if a particular schedule satisfy those recoverable schedule conditions, then we call these schedules are recoverable schedules, right? So here, the recoverable schedule conditions, right? Recoverable schedule conditions. So, first one is actually there are two conditions. First one is a schedule is recoverable if no transaction T in S commits until all transaction T dash that have written some item X that T reads have committed, right? If I read it again, uh, schedule S is recoverable if no transaction T in in schedule S commits until all transaction T dash that have written some item X that T reads have committed, right? That means if a particular uh, operations, right, or item, sorry, if a particular item is read by uh, transaction in a schedule, then that uh, item is written by someone, right? Someone, right? In another transaction, then that written should be uh, committed first, right? Uh, then that kind of transactions are recoverable, right? If I say again, if a particular item X, right? If a particular database item X, then one is written something, right? Then one transaction is written something or modify something that uh, on X, right? That X is modified by someone, some transaction, right? X. Then what happened? Another operation, another transaction is uh, access or read that modified X. So if that schedule that recoverable, then uh, that the transaction who modified the transaction who modified the uh, X should committed first uh, before the uh, transaction who read that modified item, right? So that means actually if a particular transaction is modified something that should be permanently saved to the database before uh, other transaction who read that item, right? That means so you can understand with that example. Uh, Here, second one is T dash should not have been aborted before T reads item X, right? Okay. Uh, Here, that means T dash is done the modification, right? T dash is done the modification, so it should not aborted before T reads item X. So he can't abort before read uh, before that T, right? T dash can't abort uh, before T. That means if we take this example, uh, actually I have a different document. You can understand it easily. Here, A is recoverable due to no commits, right? You can see this one right here. If you know, if there is no commits and abort, no doubt about that, that schedule can be recovered, right? The recoverable or not recoverable is coming with that commit and abort, right? If there is no commit and abort operation, that means definitely that schedule can be recoverable. Here, SB also recoverable due to rule 2, SB R1X, W1X, R2X, W2X, R1Y. Here, Y, R1, that means transaction 1 read X, right? Again, transaction 1 read it. Then transaction 2 read it. Again, transaction 2 write it. Right? So abortion is done by T1, no? T1, right? Then therefore, according to the rule, we know abortion should be done by T1, no? T1 here because right should be, because we have to consider here, first we have to see whether this one okay, right? Uh, this one okay, that means commit. There is no commit, no? That means we can ignore this one. There is no commit. Then we have to think whether T dash should not have been aborted before T reads item X. So this condition. So we can go through this. We have different different document. You can see it. Here, recoverable schedule. A recoverable schedule is a schedule in which transaction that reads data written by another transaction does not commit until the transaction that produces that data has committed. This ensures that the database can be recovered correctly if transaction fail, right? So, what is recoverable? If we take, that's what mean by recoverable schedules. So why recoverable schedules are important? Recoverable schedules prevent transaction from committing based on data that may later become invalid, right? So rule 1, these are the 2 rules. First one is, so rules which we are discussing in that slide. So rule 1 is, if transaction T reads a data item X that was written by transaction T dash, then T must not commit until T dash commits. So I think you can understand it clearly. So this T is read, T is read what? This written by T dash, right? T dash. So T dash written, then access T1. Then the rule what say? T must not commit until T dash commit. That the transaction who written should commit first. It means their modifications should be saved to the database permanently. Then whatever modification after that using this X, right? should be committed, right? So here T1 write X. This is the order. This is the step. T1 first T1 write X. Something write on X. Then T2 read X. Here this is the order for the rule 1. Commit T1 because modification done by T1. Then T1 should commit. Then T2 can commit, right? This schedule is recoverable because T2 commits only after T1 commits, right? That means modification, the transaction who did the modification should commit first. Then other one can commit, right? Then the rule 2, a transaction should not be written by another transaction that has already been aborted, right? If a particular uh, transaction abort, uh, then that record, uh, those items should not read by others, no? A transaction should not read data written by another transaction that has already been aborted. Already data items which are coming from already aborted transaction should not read. Here T1 write, then T1 abort, then T2 read. So this is the correct thing, right? This situation is not allowed because T2 would read item. Actually, this is wrong. No, this one is wrong. This situation is not allowed because T2 should be reading invalid data. Right here, these are the 3 examples which are in the slide. SA, R1X, R2X. Here, there are no commits for abort operation. Therefore, the recoverability condition is not violated and the schedule is recoverable. So, if there is commit and abort, then we should check these 2 rules. But in this essay, there is no commit and abort. Therefore, we don't need to consider these rules. Then that means is scheduled, recoverable. Then SB, what happened? R1X, W1X, R2X, W2X, R21, and A1. That means abort, right? Here, what happened? T1 write X, T1 write X here, T1 write X, and T2 read it. Then T2 read it. T2 read its things written by T1. Then T1 abort, right? T1 abort. Since T2 is not committed, recovery is still possible. Therefore, the schedule is recoverable, right? Uh, because even though T2 read it, right? And T1 uh, T1 written something or modified, then and also the T1 about the transaction itself. Then these modifications are modifications are still used by this transaction T2, but T2, even though T2 used this modified data, that T2 not committed. That means unwanted or dirty data is not going to the database, right? Therefore, this can be recoverable, right? I think you can understand because yeah. after aborting A1, that means this everything will be deleted. No, everything will be deleted, but still R2 this T2 using this modified data, but it is not harmful to the database because this uh, T2 is not saving those things, right? T2 is not permanently saving to the database. Then that means due to not saving this modification, then there is no inconsistency. Then that means we can recover, right? Database. I think you can understand uh, what is this recoverable and not recoverable things, right? That's you can understand a recoverable schedule ensure that if one transaction read data produced by another transaction, it does not commit until the transaction that produced the data has unsuccessfully committed. This prevents the database from becoming inconsistent when a transaction fails. If a particular transaction change data, then that transaction should change those data, right? That transaction should save permanently the data. Otherwise, database may in inconsistent situations. So this will prevent by using these two rules, right? So I think you can understand it now. And finally, you can see another example. This is the exactly same as what in the document is right. So not this exactly same what these conditions are saving, right? With a different example, right? So I have given two different example for the for describing two conditions, right? So then you can go through it and have an idea about these two conditions, right? Here, for example, if there are two transactions T1 and T2, the schedule is recoverable if T1 should commit first before T2 commits when T2 reads item X, uh, which is written by T1, right? That means something, this X is modified by T1, then that T1 should commit first before the T2. So if so, the modification done by T1 is permanently saved to the database, then we can recover the database if a failure occurs. Then for condition 2, T1 should not abort before T2 read X, right? For condition 2, T1 should not abort before T2 read X. That means after T2 read X, T1 can abort because X is written or changed by T1, right? Uh, here, uh, uh, X is written by uh, T1. Then X is written by X is read by T2, right? T2. Then here A1. Abort can be run at last, right? So that means still when T2 is reading this item X, still T1 is not aborted. No? Then after reading this modified X by T2, then A1 is aborting, right? That means T1 is aborting. So that means any transaction not reading values which are already aborted, right? So therefore it is recoverable. Then here, if this A1 operations comes before the this R2X, this is not recoverable because this T2, this T2 reads item X, which is already aborted, right? So this X is modified by T1, then itself aborted, then that T2 is reading values which is aborted. So this is not allowed in this condition 2, right? So that is condition 2. So I think this is not recoverable. So to be recoverable, these two conditions should be satisfied. So I think you can understand. So you can go through these things and can understand what happened when recoverable and not recoverable in schedules, right? So these conditions. So these are important. Have an idea about that. Then finally, this is also example here recoverable schedule. This SA dash is recoverable because here R1X, R2X, W1X, R2Y, W2X, C2 here. C2 is, that means transaction 2 is committing before transaction 1, right? Here, that means right here R1 is read, right? Read item X. Then this item is written by transaction 2. Then it is modified by transaction 1. Then again, this transaction 2 is modified. Then transaction 2 itself committed, right? That means modified transaction should commit first, no? So this item is modified by transaction 2, then transaction 2 itself committed. So that means before T1, right? So that means this condition 1 is satisfied, no? Satisfied, therefore this one is recoverable. Then here this SC is not recoverable because T2 reads item X from T1, but T2 commits before T1 commits. Right here, this commit is a problem here. I think C2 because here very clear, no? Very clear. Transaction 1 is written on modified X. Then what happened? Transaction 2 is read the modified data, modification done by transaction 1. Therefore, if it is recoverable, what happened? What should happen? C1 should commit, no? C1 should commit. right? That means a modification done transaction. The transaction who done the modification should commit first. But what happened? Modification done transaction, not done the commit, but another one, the modified data is written by transaction 2, that that reading transaction is committing. So this is not allowed by this condition 1. So therefore, SC is not recoverable, right? Recoverable. Then there is about T1 about also. Anyway, using this C2 thing, we can say this is not recoverable according to this condition 1. Then SD and SE, Schedule D and Schedule E are recoverable, right? Recoverable because here you can see C1 is committing first. That means here you can see W1. Transaction 1 is written, right? Then transaction 2 is accessing those modified data modification done by transaction 1. So therefore, the transaction who did the modification should commit first. That means C1 commit first and C2 next. So that is okay. That is perfect. According to the rule 1, we can say ST is recoverable. Then we don't need to think about this condition 2 because there is no about condition about operation in this SD, right? Then also this already condition 1 is satisfied, then already recoverable. Then we don't need to consider the condition 2. Then E, schedule E, what happened? A1, A2, here this is recoverable because we can here W1, right here. Condition, according to condition 2, actually in schedule E there is no commit, therefore we don't need to think about consider this condition 1. Then we can only consider this condition 2. Then here what happened? A1, right? A1 means about 1. This modification first done by transaction 1. Then transaction 2 is read that modified data. So therefore, these modifications done by this transaction 1, then that transaction aborted itself. So that means it is according to the condition 2. So that means condition 2 is satisfied. So R1 is recoverable. Sorry, SC schedule is recoverable. I think you can understand it, and it's a simple thing in behind in this recoverable and non-recoverable schedule. So you can understand easily. Okay, that's it. Recoverable schedules and also this second lecture, that is characterizing schedules based on recoverability, right? So I'll stop the lecture. So next week, Tuesday or Friday, sorry, Wednesday or Friday, we can do another rest of things. Anyway, okay, I'll stop the lecture. Okay, for today, right? Thank you.